So, hello everybody to the next talk. Little technical talk about some nice feature of Eclipse, which is sometimes not widely known. So the title of my talk is Eclipse Equinox Weaving and AspectJ, how to work around problems in other people's plugins. So now my name is Andreas, I'm from Itemis. If you know Xtext or some other open source projects, that's what we do. We do a lot of consulting projects, etc., around the Eclipse platform. Some of you might have attended one or the other automotive talk today. So if you have done this, you have learned that Eclipse is a strategic thing in the automotive industry on building tool platforms for the automotive software engineering. And what I'm showing you today comes from some experience that we had in a research project called EMIS, where we work together with companies like BMW, SimtaVision, Fortis, and Validus to build yet another software engineering toolchain for embedded systems in the automotive industry. And the idea is to show to the companies like BMW what can be done by actually combining several Eclipse projects, building on Eclipse projects. And the talk today is on what problems you can encounter when combining plugins from different projects and sources, and the interoperability, and a little known way on how to work around those problems. So to give you an idea about the complexity of what we have been doing in what kinds of scenarios you can apply, the ideas that I will show you is to give you an idea about the tool chain that we built. So we have an Eclipse-based tool chain that supports basically everything from requirements capturing. There's the Eclipse project RMF, Requirements Modeling Framework, which supports requirements. Going through features and variants modeling with Eclipse feature modeling tooling. Then we have high-level functional architecture for the software engineering, where we use the new ERTOP project to model logical architectures. We have functional design. There's the Eclipse DAMOS project, which you could think of as a lightweight MATLAB Simulink alternative. Then we are using the RTOP project to model software architectures and build on top of that. And downward, it is another thing is RTOP again, and then there's CDT, etc. In addition, we're not using only the plain EMF to store all those data, but we are using Eclipse CDO, the Eclipse infrastructure to store models in databases and to do versioning. So all this is integrated with CDO, and it's also integrated through Mylin with additional new adapters for change management, change tracking. And this is basically the high-level projects. And if you have a look at an additional listing that goes a little bit more into detail, you see also the infrastructure projects that we use here: Xtext, Sphinx, Mylin. Editors are built on Graffiti. We have Yakindo state charts. We're using Bird. For auto layout, we're using Keeler. And obviously, the expectation is we have a great ecosystem in Eclipse. We just use all those plugins and projects and assemble them, and everything works perfectly. So obviously, no, it doesn't. Because though everything is under the umbrella of Eclipse, not everything is adjusted to work with everything else. So to give you an example of the use case that we have, so obviously we have Eclipse RMF, which is an implementation of the new requirements exchange standard from the OMG, which is called RecIF. And Eclipse RMF gives you the implementation, the EMF-based implementation of the RecIF meta model, and it gives you tabular editors where you can actually edit those requirements. And Eclipse RMF is based on EMF, so it stores everything in XML files, which is the default thing to do in Eclipse EMF. But if you have a large data set, or if you have things like information protection, if you want to show those things to a car company, they will immediately ask you, can I store it in a database? Because that's what we do, and that's what our IT guidelines are. So plain XML files are nice for you, but we need database. So actually there is something like CDO, which is the framework to store EMF models in a database. And what you can do is actually just drag and drop, now with the new CDO version, just drag and drop your XML-based EMF models into a CDO view, and then it will immediately store all your data in your database, which is very nice. And then you see at the top level, you see the repository, you see a view on your session. You can open a transaction to modify the database. It's also integrated with all the editors or the extension points. So in the CDO view, you will also see open with the actual editor that you should use. So this is the RecIf model editor. That's the same thing that's registered with a standard view. And then you think, cool, it all works together. And as soon as you click it, you get an exception. And then it says, model could not be loaded. So all cool, but it doesn't play together. So then you go starting debugging other people's plugins. So, and I will spare you the exact details on how we found the culprit, but what happens is that one plugin often is not prepared about the data structures that it gets passed from another plugin. So the issue here was that somewhere in Eclipse Edit Framework, when you open an editor, you get a so-called iEditor input that reflects what the editor should open, and EMF checks that internally. And you see what happens is basically that it wants to retrieve a URI from the editor input. And what it does is it checks if the data structure that is passed in is actually an instance of URI editor input. And if that is the case, then it just returns the URI. So, but now we're coming from CDO, and AMF is not prepared for that, because what we get passed is a so-called CDO LOP editor input. And you see that does not inherit from URI editor input. So obviously, this piece of code will just return null, and subsequently, it will cause an exception. But it's a close miss, because if we look at CDO LOP editor input in detail, you see that actually it has a resource under it, and we can call get URI on that resource. So it's just almost, just almost in there. So what we would need actually is just in that piece of code, this little additional piece of code just saying, okay, if I'm a CDO LOP editor input, then do that to actually get the URI. So not much of a piece of a miss. So now what would we do to actually get that in there? So usually it's all open source, and that would not be a problem. So we could check out the EMF UI project. We could modify it, and then we might suggest the patch to the EMF project, and then AdMerx would say, no, because I don't want any dependencies to CDO, probably. We didn't try it, but that obviously could be one of the things that could happen. So actually talking to the committers, etc., would be the perfect way to actually get a problem resolved, but sometimes that would take too long, so you don't have an immediate way of fixing that. which would require to keep your own shadow project of the plugin that you want to modify. So we've been doing that. We have been modifying graffiti, checking that out, and then keeping that in our Maven Tycho build, etc., etc. So that's okay if you do it for one component, but as soon as you have several, you will have some additional stuff to be done. In addition, obviously the correct fix is always the nicer way, or the best way, what you should strive for. But sometimes you would want to just do some analysis. If I fix that, will I have additional problems to get an additional view? Or you would just want to quickly demo something to the customer where you don't want to have a full fix, but tell the customer it can be done, and then get the budget to do it really nicely. So that would be, for example, if you do a correct fix, we might have changing the class inheritance, etc. So what we want to do actually, or what we can do, is patch other people's plugins without checking out and modifying them. And what we use there is Eclipse Equinox Weaving, and in addition on top of that, that is called AspectJ. So AspectJ was well known from a, let's call it hype, that was like probably 5-6 years ago, aspect-oriented programming. Who knows aspect-oriented programming? Who uses it? Okay. So today I've been asked, is AspectJ still alive? Because as I said, it was very well known 6 years ago or something. Yes, it is still very well known, it's still alive. And you can actually use it perfectly to solve some of your problems. So I will go into detail about how that language works, just to give you an overview how to fix problems like that. The language gives you an idea or the possibility to actually specify where you would like to hook in. And obviously, we would like to hook in into the code that we want to modify, which would be edit UI util get URI. And then we can actually introduce the code that we just mentioned that we would like to have in there. And then it will get loaded, woven in at class time, at class loading time. And any invocation of actually get URI will execute our code. So I'll go into the detail of how that language looks in a second, just to give you an idea of what has to be done before. So obviously you would have to specify where to patch in and what the patch should look like. And then you have to do a lot of configuration stuff. So the plugin that provides your patch needs to have in the manifest the Eclipse supplement bundle that says which plugin I'm going to patch. So I'm telling you all that so that you have the slides, and if you want to do it, you can just use that as a cooking recipe. So we are going to patch the plugin that has the code that we want to modify. And then comes a lot of runtime configuration, which I hope those slides can help you with if you would actually want to do it, because it's a little bit difficult to find the concise all the information that you want. You need to have a number of bundles from Eclipse, the AspectJ bundle, the Weaver bundle, both set to run level 2 and automatic startup. So it has to, those cannot be lazy loaded bundles on starting Eclipse. They have to be started up automatically, and then they will hook in and do all the fun. And you would have to provide this argument to the JVM as well, so that the weaving actually gets activated. And then you could have some additional options to get detailed output to know what's actually happening. And that would be basically what you should be doing. And then when you start up your runtime Eclipse the next time, you will see a lot of additional red lines saying, okay, the Equinox Weaving is Equinox Weaving is starting. It's adding AspectJ hooks, And some time later you see, okay, now it's starting the AspectJ weaving service. And again, our bundle gets modified. And with this new startup, tada, the actual editor will open from the CDO framework, because now when the routine gets called, our code gets called in the middle, and we can sneak in our way of retrieving the URI. This is a very nice way to work around. And to give you an idea about what this actually means from a semantic point of view, this is AspectJ on one slide. For those that are using it, they know that it's much more complex, but we have a specific use case, and it's really worth looking into it. So AspectJ has several concepts. So a join point is a well-defined point in the program flow. So it's just a point in the program flow. And then we have a point cut that picks out a specific join point in the flow. And that is basically the first statement. So this point cut, the point in the flow, is actually specified as the execution of the method that is specified in the brackets. So by the point cuts, we have an option to actually specify where we want to hook in, and the point cut just gets a name that is defined by us, which we call CDO patch, and the argument specification. And then we have the advice, and the piece of advice is the code that is executed when a join point is reached. So when the join point of the execution of the getURI method is reached, by the dynamic class loading and modification, it will just sneak in our code. So our code will get called whenever the method is being called. And then basically what we're doing is we check if our data structure is passed in. If so, we sneak in our code. And then this has a special method or special function call, which is a keyword which is called proceed. And proceed just says, call the thing that we actually override. So basically, proceed will call the original getURI. So we can say, in our specific use case, we sneak in our way of retrieving the URI. And if that doesn't apply, just go on with what has originally been implemented in EMF UI. So actually, the AspectJ stuff is much more complex. You can actually sneak in. There is not only execution, you can modify when a function is called, not when it's executed. So execution will sneak in basically when getURI is entered, but you could also modify before it is called or after it is called, and there's a whole bunch of things that you can do with AspectJ. You can override constructors to actually return different objects, and it's really big and things, really major things, and that is basically condensed the stuff that we used to actually patch the projects that we have. This is another very similar thing. Also Graffiti, the Graffiti graphical editing framework is not prepared to get models passed in that come from CDO. It is prepared to get models in EMF passed in. The diagrams are also modeled in EMF, passed in as EMF models. And it's very similar. We are patching Graffiti here. And Graffiti has the new concept of a diagram editor input, which is constructed from the URI. And so we can patch it, and then the Graffiti editor will actually open and work on models in CDO. This is something, we have a project that actually listens to an editor ID, and the editor ID has changed. It checks for a selection, and then suddenly the editor ID of the commercial project that we use has actually changed. And now we are using this to patch the code to work with the old editor ID and the new editor ID, because some piece of code expects a specific hard-coded editor ID, which it doesn't get anymore. It gets a different editor ID. And now we are telling it, OK, if you're getting the new editor ID, just assume it's the old editor ID. There's a lot of stuff that you can do. Some of you might think this is hell, and it actually is. So AspectJ is a strong tool, but if you want to have a look at it, be aware of the use cases that you do. Because obviously what you see right now is the actual program flow is not deductible from the actual code anymore. So if you look at the code of edit UI util, you will not see our specific handling of the CDO lob editor input anymore. So you need to be aware that there is something that gets injected, but that is not easily inferable from the code anymore. So it needs good documentation telling people, be aware there is something here that gets injected. That's something that you should really be aware of. On the other hand, this is really dangerous because nothing lives longer than a quick fix. So don't tell anybody that you did it. It should not replace a real discussion or a real investigation of the problem and a good solution, a long-term solution. But for example, we have some things that we need to discuss where we say, OK, we need to get both into a discussion with Eike Stepper from CDO and Ed Merckx from EMF and have a longer discussion on what would be the best solution. And sometimes you just cannot do that. You just want to demo something, you need to prove something, or you need to analyze something. Then that would be one of the solutions that you could do. And especially Eike Stepper, when I showed him, because he was involved in the project, he said, oh my God, I will be getting some strange Bugzilla entries for CDO from that, because people will be patching stuff, and I will not be able to actually reproduce it. So that's one of the caveats that you should really take into account, not to really use that for a long time, only for fixes. On the other hand, it's really a fast way to find a root cause, because sometimes you encounter null exception, and then you say, OK, maybe I could fix this. And then you do all the work, maybe do a nice bug fix, and then you just find out that this will just lead to another bug exceptions half a minute later in a different piece of code. So it's a fast way to patch code to actually get an idea of what's going on wrong, and will it work when you fix it, and what will be the follow-up problems. And obviously, it's a good way to understand what's happening, and if the problem that you think there is can be fixed, and in situations where you need a fast fix, it's really a nice solution that does not take a lot of administrative overhead. So for us in the project, the goal was to prove that the Eclipse tools can be assembled to a automotive tool chain and not fix every problem that comes with that. So that would be the easier solution to actually fix this stuff. And also, we didn't have the resources, basically, to really think about it. So they took me as the project manager to get in the quick fixes and stuff. Yeah, so that was the overview on what you can do with AspectJ and actually patching classes at load time. And I'm open up for questions now. Marco. Is there some debugger support for AspectJ? Or you can reach a code which has been injected? When it jumps to the file and classified it? I think so. I think so. Maybe the AspectJ, I wanted to try it this morning. I think so that it does. It actually patches the code to go to the correct place. Yeah. But still, you don't. Sometimes you just look at the code, you navigate with hyperlinks and find references. And that, yeah. Exactly, exactly, yeah. And it's completely integrated in the JDT, so it's a nice tooling as well. Yeah.
Does putting weaving on slow down the startup of the platform?
A little bit. So I didn't find it that it extremely starts up the platform, slows down, because you specify the plugins actually that gets patched. So it knows when to actually do some patching. Yeah, but it's still reasonable. And I've seen it done in commercial projects, not in AspectJ, but with the weaving hook with an own patching. It's okay. So in our implementation, we have the JDT in as well. Then it slows a little bit down because it starts to patch the GDT as well, because that comes with it. But it's reasonable.
Just a comment. There's a caching addition to Equinox Weaving. So the second time you start up the system with the same configuration, so the same plugins installed, same aspects and same other plugins, there's no overhead at all anymore.
Okay, good to know.
It's just the actual weaving after the first time it starts up. Second time it's at the same speed as without weaving at all.
Yeah, I hope that getting out the information about weaving is useful for several people, because I think it's one of the, obviously you are familiar with it, but it's something like not an undocumented feature, but a really lesser known feature of what can be done. So any other question? Okay, then thanks for attending and enjoy the rest of the conference.